Hello. Today we are going to do the lab of distillation of hexane and cyclohexanol. So, first thing you want to do is go weigh your 100 ml round bottom flask and your 50 ml round bottom flask. And the other thing that's probably good to do is your boiling chips. You're going to want to go weigh those as well. Those will influence your weight at the end. I have weighed all my stuff already, and the boiling chips for me add about an extra gram. So at the end, that'll be a significant amount. So the first thing you want to do is grab yourself a heating mantle and a stand and just place it on so. And don't plug this in yet, as you don't want it to get hot or turn on. So first thing, you're going to put this in the clamp, and you're going to clamp it by the round bottom flask and leave it just above your heating mantle. So now the next thing you need to do is assemble your distillation apparatus. So you're going to use your 3-way connecting tube. You're going to want both the ends sticking up, not down. I'll show you when we hook the water up. And you're going to have these blue clips here. These only go on one way. You can see there's kind of a big end and a small end. Same with the clip. So they only go on one way. If you put them on the wrong way, they're going to break. And on the other end, you're going to put your vacuum tube just on the bottom, and you're going to clip it the exact same way. And now you have your distillation apparatus put together. So once you have that, you're also going to want to get a 250 ml round bottom flask, fill it with some ice and water, and this is where your 50 ml round bottom flask is going to go. So you just set it in there, don't need very much, and there you go. Next thing you want to do is take your cyclohexanol hexane mix and add it to your 100 ml round bottom flask and put your boiling chips in there as well, just like so. And then you're going to put this on. I have this a little too high, so you can lower it down. And there we go. So you can see it fits perfectly into your round bottom flask. And the other thing you're going to aim for is so this is straight up, and that this is in the water here, or the ice water. The reason we clamp by the round bottom flask here is because all the weight will be on here, and then if you clamp on here, the round bottom flask will fall out, which is what you do not want. So the next part, what you wanted to do is set up your thermometer. Now, when you're doing this, don't hold it really far away because it can bend and break, so push it really close. And it just goes in like so. Now, you're going to put it in here, and you're going to probably have to adjust it. As you can see, my thermometer goes down all the way there. That's too low. If it's too low, it's going to give you a false reading, and it's going to read too high, versus if it's too high like this, where it's up here, it's going to give you a false reading, and it's going to be too low. So if you want it adjusted, just so it's right about here, this is where your vapors will be that you want to read the temperature. That'll give you the most accurate reading. You can, and when you're adjusting this, Make sure you're always close to the end. You can and pull it out when you do it, just so you don't break it. This is how it's supposed to be set up. You can see it's nice and straight. Give our ice water, it's good. Now what we need to do is hook up our water. So what you do is you take one of your handy dandy hoses, put it in the bottom here, and the bottom is what's going to be hooked up to the sink. So the bottom hose, or bottom fitting, goes to the sink, as you can see. Now the top one, all you do is just hook that up. You just put it down the sink, and there you go. So now turn on the water. You don't need a lot of pressure. Too much pressure, these can pop off and you're going to flood the bench, which will give you a big mess that you don't want to clean or ruin your papers or somebody else's papers. So you just need a very low pressure of water. So next thing you'll do is raise this up. You're just going to have it so this is gently touching it, and then you're going to plug in your power to your mantle. And so this here, you can see all you're going to do is turn it up to 40, light comes on, and now you play the waiting game. As this is warming up, what you're going to be looking for and watching is your thermometer. It's going to warm up to the lower boiling point between the hexane and the cyclohexanol. Hexane's boiling point is 68.7, cyclohexanol is 161.8. So what that means is once this starts boiling, evaporating, and distilling, that this should heat up to 68 degrees. And you're going to watch it as soon as at that temperature, because as soon as all your hexane's done evaporating and distilling off, this is going to start to drop really fast, or it's going to start to rise. So as soon as it starts doing that, you want to shut your heat off and remove this from the heat source so it doesn't boil any of the cyclohexanol off. Otherwise, you won't have a pure sample of hexane in your 50 ml round bottom flask. It's boiling, and our temperature has gone up to about 67 degrees. And again, if it's too high or too low in there, then it might read high or low. So I might be able to get a little bit more accurate if I lower it down a hair, so that's okay. But you will see eventually hexane will start coming down here, it'll distill, and it will fill up your round bottom flask. You can see there's hexane that's dropping down here, which is what's distilling off right now, and you'll see this for quite a little while. Alright, so the temperature is starting to rise, which means that it's all finished, so you can remove the heat. So if this worked out properly, in your 50 ml round bottom flask, you will have only hexane. In your 100 ml round bottom flask, you should have only cyclohexanol. So you're going to want to let this cool down for a bit, just in case there's any hexane that's left in there that's still condensing, so you can have the highest yield possible. So once it cools down, now you can shut your water off and then remove everything. So take this off, lift this off, take your thermometer out. So when you're disconnecting this, because it's under vacuum, There's an easy way so you don't spill water everywhere. Take the ends off if you want. Might make it easier. Because if you take off this hose or this hose, water will go everywhere. So if you unhook the vacuum and then hold the hose up and then let gravity do everything, and it drains out all the water, and when you have no water in here, and it doesn't make a mess. So before you go weigh them, make sure these are very dry on the outside as it was in cold water. That extra water on the outside is going to add weight, and it's going to give you a false reading in terms of your weight of solvent in there. So I weighed my yield here on both of them. I ended up with 3.916 grams of hexane and 7.643 grams of cyclohexanol, which gave me a total of 11.603 grams, which was an 89% yield. And what we're using for this is 13 grams weight approximation according to the lab manual. So that gave me an 89% yield, which isn't bad. Some of it could have got stuck in the condensing tube, a thermometer, other places. So that could be why. I also could have measured a little lower than the 15 mils that was required, which also could have made a little bit low. And that's what we're going to do, is make 6 test tubes. 3 are going to have cyclohexanol, the other 3 are going to have the hexane, and you're going to put 20 drops of your compound in each test tube. So just a tip when you're doing this, it's good practice. When you fill up your washer pipette, you always want to kind of keep it flat or pointed down. The reason being is if you have something in here like this, if you tip it back up, everything's going to go from the top down to the bulb, and you don't know what's in this bulb here. So you could contaminate your product. So it's good practice to always kind of keep it pointed down just a hair, just so it doesn't run back. Otherwise, it can cause issues. So the next part, what you're going to do is a miscibility test. That's going to see if it's miscible or immiscible with water, ethanol, or ether. Miscible means it will mix and it will be one clear mixture. Immiscible means it will not mix and you will see a bilayer or 2 different mixtures, and I will show you here in a minute. So you're going to add 1 mil of each into one of your 3 samples of cyclohexanol and then one of your 3 samples of hexane. So as you can see, there's kind of 2 distinct layers there. So that would mean that this cyclohexanol with water is not miscible. Be sure to shake it to make sure. 2 layers, it wouldn't be soluble. But now, go over to this one. This is ethanol. You can see there's no bilayer. Okay, so that would be considered miscible. And if we look at the cyclohexanol and the ether, there is no bilayer, so that would be miscible. So the theory of this is that like dissolves like. So if you have a polar solvent in a polar compound, they will mix with each other, and if they aren't, and it's a polar compound with a non-polar solvent, it won't mix. So in this one here, this is the water with hexane. Hexane's extremely non-polar, and water's as about as polar as it gets. You can see they don't mix because they're not the same polarity. So that would be considered immiscible. Where if you look at this next one, the hexane and ethanol, these do mix. So these would be miscible. And the final one, which is hexane and ether, you can see there's no bilayer, so that means these mix, they are miscible. For your final step, you're going to perform a Jones oxidation test, which is this stuff here. Please be careful with it, it is not safe. It contains chromic acid, sulfuric acid, and it will hurt you. So, you take 3 drops of your compound, this is the cyclohexanol, with 10 drops of acetone, and all you're going to do is add 1 drop of your Jones agent and watch what happens. So you can see this changed from orange to a kind of a pretty bluish green color. So that means it reacted with your compound, which means something oxidized. So I mean, because of the alcohol on here, it got oxidized to a ketone. So that means that you have a pure compound there. Now, if you do it with your hexane, this shouldn't change. So we will find out. So as you can see, that stayed orange. So that means there's nothing oxidizable, because hexane is just a straight carbon chain. So there's nothing for it to react. So that means that you have a pure sample of hexane, which is a good thing. So, and that pretty much concludes the end of the experiment.